Hello again. Welcome to part 4 of relations and functions. In this video, we talk about the quadratic functions, and we talk about what the graph looks like, the basic graph, and then I show you how to solve a quadratic equation using a couple of methods. But first of all, a quadratic function looks like as shown. So we'll name it p of x. You perhaps remember that we saw these earlier on when we're dealing with polynomials. It turns out that the quadratic function is actually a polynomial of degree 2, where that means the highest exponent in the expression is 2. So it looks like this. P of x equals to a times x squared plus b times x plus c, where a, b, and c are some real numbers. You recall this expression, we used that previously. So a, b, and c belong to the set of real numbers, and your a has to be different from 0. If your a is 0, what that means is that first term, ax squared, disappears from there. It will just be 0, and you will have bx plus c, which will not be a quadratic function. Okay, so your a has to always be different from 0. So this is what a quadratic function looks like. Now specifically, if we let a be 1, b be 0, and c be 0, what do we have? Well, our p of x will just become as shown. It will become x squared. B times x will just be 0 times x, and c will just be 0, so that goes away. You have p of x equals to x squared. This means that this function p takes on a value, or takes on a real number, and relates it to the square of that real number. That means p of x equals to x squared. This is called the square function. You will recall that we said that these functions have names, right? And they do things. So this one squares anything that it takes on. The absolute value function takes on a real number and returns the absolute value of that number. The square function takes on a real number and returns the square of that real number. So let's see what the graph of this square function looks like. This is the basic parabola. This is the basic quadratic function. The graph of it, what does it look like? Well, like we did previously, we need some x's. We need some values in the domain of the function. So I've chosen some values here, -3, -2, -1, 0, 1, 2, and 3. And for the dependent variables, the y's, you will get the y's by simply squaring the dependent variable, x. So if you do this and you square -3, you will get 9. So -3 squared is 9. That's -3 times -3. If you do the same thing to -2, you will get 4. If you square -1, you will get 1. The square of 0 is 0. If you square 1, you will get 1. If you square 2, you will get 4. And if you square 3, you will get 9. In terms of ordered pairs, we can represent these values as shown. So -3 is related to 9, -2 is related to 4, -1 is related to 1, 0 is related to 0, and so on. That means that if you square -3, you get 9. If you square -2, you get 4, and so on. So this is the function in terms of ordered pairs. What will this look like graphically? Well, you can see, so I've put my x and y axis in there, and I have 5 and -5 on the y and x axis. The point of x you can plot. The point of the function we can plot on the graph as shown. You can see -3, 9 up there, and -2, 4, and then -1, 1, and 0, 0 is right at the origin, 1, 1, 2, 4, and 3, 9. If you join all those points with a line, you will get something like this. It looks like a U, right? That's the parabola. It's the basic parabola. It is the basic quadratic function. My arrows there indicate that the function keeps going on and on and on. Our picture can't handle that, but this is good enough. This just shows that it keeps going on and on. Since you can square any real number, right? There is no real number that cannot be squared. Okay, there's no problem with that. That means that the domain of the square function is all real numbers. So any real number will be acceptable into this function. And the range, you can see from the graph that the lowest value of y for the dependent variables is 0. right? The graph does not dip below the x-axis. So the lowest value there for the y values is 0. That implies that your range will be all real numbers greater or equal to 0. We can do the same thing for any quadratic function. All we have to do is just pick on some values of x, and we find the corresponding y values, and then we put them on the Cartesian coordinate plane, xy, and then we can connect all the points together. We will get a graph that looks something like this. Then the next thing that I want to talk about is how to solve a quadratic equation. Now, our quadratic function, we said, is f of x equals to a times x squared plus b times x plus c. What are the values of x for which that quadratic function equals to 0? That's what this equation means here. So whenever we have a quadratic equation, we can always rewrite it and rearrange it, and eventually it will look like this that I have here. I will show you a couple of methods to solve a quadratic equation. The first one is by factoring. You remember we talked about factoring in module 1, how to factor a quadratic equation. We're going to use that here, so you need to remember that here. Then I will show you how to solve a quadratic equation by formula. The third method is by completing the square. It's very similar to the formula. I will not be talking about completing the square here, but it's fairly close. The completing the square is obtained from the formula, so we'll just restrict ourselves to the formula in this case. Okay. Now, what is the formula? The formula is x equals to minus b plus or minus square root of b squared minus 4 times a times c divided by 2 times a. When I was in school, this formula we used to call the almighty formula. There's nothing almighty about it. It's just that you have to find the a, b, and c, and then you plug them in here, and you're done. One key thing to note is that b squared minus 4ac has to be greater or equal to 0. The reason for that, you will remember from our dealing with radicals, that you cannot take the even root of a negative number. So that's why this has to be non-negative. And like I said before, the completing the square method is very similar to the formula, so we will not be talking about that here. So for example, let us solve this quadratic equation. 4x squared equals to 8x plus 5. You will see that this doesn't quite look like the standard ax squared plus bx plus c equals to 0, but we can rearrange this. If we rearrange this equation, we would have 4x squared minus 8x minus 5 equals to 0. And then you will remember that we know how to factor a quadratic equation of this type. How do we factor this? Remember we said that we have to look for two numbers. We have to look for two numbers that have two characteristics. The first characteristic is that the sum of those two numbers have to equal the coefficient of x, which is negative 8. And if you multiply those two numbers together, your result has to be the product of the leading coefficient, which is 4, multiplied by the constant term, which is negative 5 in this case. So 4 times negative 5, we get negative 20. Well, if you think about that a little bit, you will see that the numbers you're looking for are negative 10 and 2, because negative 10 plus 2 is negative 8, which satisfies our first condition, and negative 10 times 2 is negative 20, which satisfies our second condition. Next, we will rewrite the middle term using these two numbers we have found. So the middle term is negative 8x. We can rewrite that as 2x minus 10x. That gives us our negative 8x. So that our original equation, 4x squared minus 8x minus 5 equals to 0, is the same thing as 4x squared plus 2x minus 10x minus 5 equals to 0. We can then pair these up like we did when we were talking about factoring, and the greatest common factor for the first two terms, we will factor that out, and we'll do the same thing for the second pair of terms. And you can see now that 2x plus 1 is a common factor. We can rewrite that, and we will obtain 2x plus 1 times 2x minus 5 equals to 0. So we have now factored the left side of the equation. Now the next thing is to think about the meaning of this product. What does it mean when you multiply two real numbers and your result is 0? Well, if two real numbers are multiplied together and the result is 0, at least one of those two numbers has to be 0. That's what this statement here means. So if a times b is 0, either a is 0 or b is 0. we can apply that to our factorization of this quadratic equation here, which would imply that 2x plus 1 times 2x minus 5 is 0, implies that 2x plus 1 is 0, or 2x minus 5 is 0. These are a pair of linear equations which we know how to solve. If we solve these, we'll get x equals to negative 1 half or x equals to 5 halves. This will be solution to our quadratic equation. But are these actual solutions? Will these work? If we plot them back in the equation, we can check to see if that is the case. For the first solution, x equals to negative 1 half, if we substitute that into the left side and the right side of our equation and simplify, you will see that on the left side you will obtain 1, and on the right side you will also obtain 1. So that means that works just fine. And similarly, if x equals to 5 halves, we can substitute back into our original equation and see what we get on the left side and the right side. We will get 25 for both sides. That means that our solution to the equation is x equals to negative half and x equals to 5 halves. Now, what if we want to solve this equation by using the formula? The formula we introduced earlier on, x equals to minus b plus or minus the square root of b squared minus 4 times a times c, everything divided by 2 times a. All we have to do is, once we have written the equation to look like the standard, we can compare them. And we'll figure out what a, b, and c should be. In this case, your a will be 4, your b is negative 8, and your c is negative 5. Next, we'll substitute into our formula. We'll have x equals to negative of negative 8 plus or minus the square root of negative 8 squared minus 4 times negative 5. Everything under the square root, and everything we are going to divide by 2 times 4. We can then simplify this. Okay. If we simplify this, you will get, as shown, 8 plus or minus the square root of 64 plus 8 divided by 8. And that will equal 8 plus or minus the square root of 144. The square root of 144 is 12. You will get 8 plus or minus 12 divided by 8. And if you simplify this, you will get that your x is 5 quarters or negative 1 half. You will see that is the exact same thing that we obtained when we used factoring to solve this equation. So now, you try your hand on these two examples. Like we've done previously, you need to pause the video right now while you try and solve these equations. And once you have finished, you can continue the video to see what I have done. So go ahead and pause the video now. So, what did you do? Well, for the first one, here's what I did. If you rewrite that quadratic equation, you will have 3x squared minus 4x plus 1 equals to 0. That looks like the standard. Now, to factor this, we are looking for two numbers that will add up to negative 4 and that will multiply to 3. Your numbers, if you think about that you're looking for, are negative 3 and negative 1. We can then rewrite our equation and factor as shown. It will factor as x minus 1 multiplied by 3x minus 1. And since we are multiplying two numbers, x minus 1 and 3x minus 1, and we're getting 0, that means that either one or the other will be 0, like we discussed previously, and that will imply that your solutions there will be x equals to 1 or x equals to 1/3. And if you substitute those values back in, you should see that there's no problem there. And for this second example, this one won't factor. I hope you observed that it didn't factor, and since it won't factor, using the formula is the way to go. If you compare this equation to the standard, you will see that your a is 3, your b is negative 4, and your c is minus 1, which if we substitute back into the formula, we will obtain as shown. We can then simplify this, and our result will show that x equals to plus or minus the square root of 28 divided by 6. But you will remember when we talked about radicals that square root of 28 you can simplify, and your result will be 2 root 7. We can then replace root 28 in our solution as you then get that x equals to 4 plus or minus 2 root 7 divided by 6, which if you simplify, there's a common factor for the numerator and denominator. Common factor is 2 there, or greatest common factor is 2. If you simplify that, you will obtain that your x equals to 2 plus root 7 over 3 or 2 minus root 7 over 3. That will be the solution to the equation. And you can see that the solution is not very nice, right? You're having irrational numbers in there. That's why it didn't factor nicely. This completes our video, our fourth part of relations and functions.